Good morning. This lab is for 6th grade. This week we are talking about characteristics of chemical reactions coming off of our week of finishing up where we left off before spring break in regards to physical and chemical properties. So today I just shared in STEM Scopes the lab in characteristics of chemical reactions titled Signs of Chemical Reaction. So I'm just going to begin by reading the introduction to this, and then I will take you through what we would have done in the classroom. Reactions between substances are happening all the time, both in the laboratory and in our daily lives. Some changes that occur during these interactions are physical, while some are chemical. Some can be quite dramatic, such as explosions, or the creation of totally new substances with strong colors or odors, while others can be quite subtle. How can we tell in the laboratory if a chemical reaction has actually occurred? So what I have done, and then it continues to read, conduct a series of chemical reactions and observe firsthand some of the indicators that a chemical reaction has taken place. So again, I want to reach out, and I've been posting this in the comments personal, private comments to students that have replied to this week's essential question. I want you to understand that you're reading. Your STEMscopedia does an excellent job of going into more detail in regards to what happens if a chemical reaction has occurred. The data table that you will see that is behind me, I will take a picture of this and post this in Classroom, is going to go through some of those maybe more obvious and maybe not so obvious chemical reactions. So we have color, temperature, gas produced, precipitate formed, and then of course finally the last column of that data table would be if a chemical change has occurred. You are going to see a chemical reaction. The chemicals that we would have used is, the first one is magnesium sulfate, MgSO4. Then we would have had sodium carbonate, NaCO3. Then we moved on to calcium chloride, CaCl, and then sodium bicarbonate, your household baking soda. To get these reactions, I needed an indicator. So this is supposed to be cabbage juice, but I did not have red cabbage, obviously red cabbage. I did not have red cabbage in my refrigerator, in my kitchen. So I got on the internet and found that blueberries also can be used as an indicator. I mixed that, boiled that with distilled water because distilled water does not have any of the impurities, so to speak, not unhealthy impurities, but minerals and the such that are naturally found in our tap water. So that's the background of the materials that I used. As you can see, I have to purchase these from my chemical company. And this is the first part of the lab, and this is what I did. So I took my indicator, I took 50, that's still warm. I'm going to get to this one, the calcium chloride, still warm on my tabletop from the chemical reaction. Remember, temperature change. Temperature change without me having to set it on fire. So I used my indicator, my blueberry, it'll say cabbage juice, same type of situation, still an indicator, and I mixed it with magnesium sulfate and my sodium carbonate and my calcium chloride and my sodium bicarbonate. And you can tell, and I will take a picture. So this is the original color of the blueberries. It's very similar to red cabbage juice. It's a red, more of a purple, right? And so this made it a little clearer, so there was a change. This you can definitely see that there was a color change. It turned it like blue-green, green-blue. This one is a much deeper purple, and then this one is blue. All right. Now, some other key characteristics, and you can read this for yourself by opening up my image, my photograph, my picture from my phone once you work through this if you would like, is I have thermometers, and there was a temperature change. Like I said, this one, the calcium, again, this is my indicator, and calcium chloride is still warm on the bottom. So this reached a 115 degrees Fahrenheit. Or as I look back here, this is my 49 degrees Celsius, which translates to about 115 degrees Fahrenheit. My sodium carbonate also warm to the touch. Also had a great, modeled a great chemical reaction for us. And it raised to about 110 degrees. We're talking about 5 to about 3 degrees in difference. That is a general rule of thumb to give you an idea of what 110 to 115 degrees Fahrenheit would feel on your skin. If you like to bake yeast bread, it is recommended that you bring milk or the water or whatever it is that is going to be your liquid in your recipe to about 120 degrees Fahrenheit. And so a general rule of thumb at my house, make pizza dough, same thing, has yeast already in it and you want it to rise, is to turn your tap water on to a temperature which you maybe think is going to be close to 120 degrees. But the trick that's been taught by a family member to me is to take the inside of your wrist and turn on your tap, put your arm up to that, and then if you can hold your wrist there for about 3 seconds, that is about 120 degrees. You can take a thermometer, a kitchen thermometer, and it's awesome science because it comes out to be 120 degrees every time I do it by just using the inside of my wrist. Again, you can hold it there for about 3 seconds and then you have to pull away because obviously the water's gotten too hot for that more sensitive area on your body. All right, so the second part of this, I'm going to move right along, I don't want to make this too long, is I have a switch here now, so you can see these, is in beakers A, B, and C, and it recommends us to do it in baggies, but a precipitate, that's another awesome phenomena that I saw. The precipitate, as you can see, this was like the oil and the water that we mixed earlier in our last unit. A precipitate is like this cloud or this separation that happens with more powerful chemicals, like in chemistry. It'll just kind of float on top and it'll look like a cloud, literally like a cloud is formed. So this one definitely had a lot of bubbles. You can see the residue, hopefully. A lot of bubbles, which is another characteristic of a chemical reaction. But we also got a separation. In our world, in 6th grade science, we're going to call that a precipitate because that's pretty darn close. So I took the magnesium sulfate and the indicator. I took what is called a pipette versus the glass eyedroppers that we use. And I placed 3 pipettes of the magnesium sulfate into beakers A, B, C, and then D will do something else. So 2, so you can watch these things. 2, baggie A. Look at my notes. Sometimes it's hard to remember. We're going to take the sodium carbonate. And I do have a thermometer because sometimes these temperatures are quite... I'm taking like this slimy green. Now it's really turned green now that we've let it set. And you can see it hopefully in your view, my video. It's a lot easier than it looks. And I'm just going to use the thermometer and I'm going to mix those up. Oh, look at what happened. I can pick it up for you. Oops, I missed it. Sludge. It's like a sludge. So the things, again, you're going to ask yourself, are we getting a color change? Are we getting a temperature change? Gas produced, precipitate, and chemical change. I will conduct as I'm videoing for you today, but I just want you to be able to see it. And I just put the wrong chemical. That's kind of cool. And the wrong. So this one was supposed to go here. Oh, I just did the same thing. That's okay. All right, and then into baggie B, we were supposed to have added calcium chloride, so I'm going to jump back because I put it in the wrong beaker, not a big deal. I'm going to jump back and put this into beaker A. Right away as it hits, I'm getting some bubbles. Let's put our thermometer in there. Give it a little stir. Okay, and we'll see if we get a temperature change with that. And then in baggie C, the sodium bicarbonate goes in there. Ugh. Kind of a nasty sound, isn't it? And we stir that. Obviously, we're getting some bubbles. And then lastly, I'm going to put calcium chloride in here. This one's a lot easier to move. And we're going to mix this guy, sodium carbonate. This one's a little bit harder. So again, this is a little bit different. I'm doing 2 different ones versus just the, I have plenty of solution in there. I'm just going to pour it because I'm impatient. And there you have it. You've been seeing use of some bubbles. You saw like a different material completely being created. And some bubbles in this one. So you're definitely seeing some chemical changes. All right, so hopefully maybe that makes sense to you now that I've shared it with you in STEMscopes. You can work through that, knowing like the chemicals. I wanted to introduce you to the chemicals that we were using and how that all obviously shows us that chemical changes, chemical reactions have definitely occurred. Happy Earth Day. I hope you guys have an awesome day. We'll talk to you soon.